Márton, you can take it away.
Awesome. Thank you so much for that lovely introduction. Hey, everyone. My name is Márton Braun. I'm currently working at Stream, where I'm an Android developer advocate and an engineer. And I'm also a GD for Kotlin and Android. Today, I want to talk about building awesome Android libraries. We'll go through a bunch of things, but to start with, why am I talking about this? The reason is that I really like building Android libraries. It's as simple as that. My first real library was DSL wrapper around Mike Pence's material drawer library, which you might have used. It was a really, really convenient library for dropping in a drawer easily into your application. Then I went on to build somewhat of a framework called Rainbow Cake, which is built on top of Jetpack concepts. It's an architectural framework somewhere between MVV and MVI. Then I built a library called Crate, which is a tiny shared preferences wrapper, which uses Kotlin delegates to make it easy to access values in shared preferences. But this is actually one of my favorite libraries that I've ever done, just because it has a really, really neat API. And lately, one of my latest libraries is called Require KTX, which is just a small collection of Kotlin extensions on common types like bundles or intents, so that you can require certain values from them, and you don't have to deal with nullability or getting default values when you're trying to get a string or an int or whatever out of a bundle or an intent. Instead, you can just get exceptions in case they are somehow missing. I haven't actually announced this last library yet anywhere, so go to GitHub and check it out and give it a star if you like it. I also do open source development as my day job, which is a great place to be. So I work at Stream, and I work on our open source Chat SDK for Android. This includes a low-level client, which does API calls for you. So you get a typed Kotlin API for accessing our chat APIs. And you also get real-time event handling. On this, we also have offline support, which builds on top of the client. It gives you caching and offline functionalities. And we also ship pre-built UI components so that it's easier to just drop in these into your applications and have a list of channels, have a messaging view, a message input view where you can send new messages, and so on. We have Kotlin first APIs. Our SDK is essentially entirely Kotlin, and we take care of giving you good APIs for Kotlin use. And of course, we are free for makers, which is something we've introduced a couple of months ago. So if you're a hobby project or a small startup, then you probably get our services for free. Otherwise, the backend part, the service part, is a paid thing. That's our business. And again, just to emphasize this, we are on GitHub. We're doing this all out in the open on the client side. So if you want to look at examples of things I'll talk about today, Gradle configuration, the publishing setup, anything like that, you'll find all of that in our repository. And you can just check out the repository in general, start if you like it, and so on. Let's jump into the meat of the topic. And if you remember one thing after this talk, I want it to be this. You should minimize basically everything in a library. What do I mean by this? You should minimize the features of a library, usually, and make sure that you're solving just one problem, that you don't try to solve like everything in Android development. Try to solve just a single problem at a time. And you should minimize your public API, your dependencies, the impact you have on the application, whatever features you're enabling by default, and also the requirements that you set for applications that include your library. We're going to go into most of these things and a lot more in detail. This is just the very brief summary of what we're going to cover. Let's start with public API. This is one of my favorite topics, and what I want to highlight here first is that you should have a minimal API. The things that you expose from your library should be as few as possible. If you've read Effective Java, you have encountered item 15 in there, which is to minimize the accessibility of classes and members. This applies even outside of object-oriented code, which I believe is the title of the chapter that this is in. In a library, it's a very good idea to hide everything that's an implementation detail and only keep the things that external clients are actually supposed to interact with. One reason for this is because it's very hard to remove anything from public API. If you've published something once as something that others could access, you have to assume that they are doing that and that removing it will break their application. So you shouldn't do it if you want to be nice to them. Deprecations are slightly better in Kotlin. We have nice ways of doing this, but it still takes a lot of effort and time. One thing we're doing in Stream, in addition to just deprecating with annotations at the code level, is that we keep a deprecations document where our clients can look at all of the features and declarations that we've deprecated. They can see when using it as a warning, when it will become an error, and when we're planning to remove it, and also some notes about what they should be doing instead. A minimal API is also easier to use. If you have fewer classes to create instances of, if you have fewer methods to call on those classes, it's easier to discover what a library does and how to interact with its APIs. And it's also harder to misuse. If you expose everything in your library, if you don't think about visibility, then your clients are going to call into random bits that you never expected them to call into. But if you minimize your API, then you can have a much better time because they'll actually use the things that you meant to give them to use. Of course, minimal API has to be achieved somehow. So it's an interesting topic, how to control the visibility of things. I've actually created an entire talk on this separately because it's a very long topic. There's visibility modifiers, there's annotation requirements, there's explicit API mode in Kotlin. There's a lot of different things you can do to do this correctly. So I want to point you to this existing talk. I have the link here, but this talk and everything else that I'm mentioning along the way will be in the links at the very end of the talk in one place. So you can just wait for that and find all of the resources down there. I'll also be giving an updated version of this talk next week at Virtual Kotlin User Group, so you can also tune in for that. One thing that's not in the talk yet, but is going to be by next week, is that you can also validate your API. We have tools like the Kotlin Binary Compatibility Validator, which allows you to dump the contents of your public API into a file and then check whether your current API has changed compared to what you have stored in the file. You get dumps like this, which you don't have to really look at in detail on this slide. The point is that you get plain text files that list your classes and all of the methods that are inside them. And whenever you change public API, you can dump this again, and that will give you a version control changes like this, so that you can clearly see in diffs what the changes to your public API were and whether they were intentional. For more about source and binary compatibility and also about Kotlin's deprecation features, you can go to this article I wrote 2 years ago about maintaining compatibility. Again, this will be in the resources at the very end. One last thing I want to mention when it comes to public API is dependencies. Here's a function in an interface that allows you to send a message. The return type is also a message because you get the send message object back after the sending operation has completed. And this is a simple blocking synchronous API. But what if you wanted to make this asynchronous? You might choose to do something like this, make it a suspending function. And this would force your clients to adopt certain dependencies. For one, they would have to start using coroutines if they're not using it already. But two, they would have to start using Kotlin if they are still writing their code in Java, because suspending functions are really, really no fun to call from Java code. So you should be considerate about what types and what kind of declarations you expose from your public API. Another approach to support Java users would be to use something like RxJava here. So I could just wrap the return type in a single, for example, or a maybe, and I could use that. But again, in this case, we would be forcing all of our clients to use RxJava, which they might not have in their application. They might not know how to use. So be very careful about enforcing things like this via your API. One thing we're doing in the Stream Chat SDK that we're just straight up stealing from OKHTTP and Retrofit is that we have a call class that you can use to run most of the operations in the SDK. So this call class allows you to execute it, which gives you a blocking method call that you can do on a background thread. You can enqueue it with a callback, which is also Java friendly. Or if you're using coroutines already, then you can await it using an extension function. Let's talk more about dependencies while we're here. Again, this is something you should minimize in a library, and there are a couple of reasons for doing that. First, there's the size. As you're pulling in more and more dependencies into your library size and the size impact on the app that's going to include your library is going to grow. Here are some stats that show you how much conversion increases as an APK size decreases by 10 megabytes. As you can see, on average, it's about 1.5% more adoption for every 10 megabytes that an APK is smaller. This depends on regions. Of course, regions where data rates are worse or devices have lower storage on average will see even larger changes in conversion depending on the size of an application. So you don't want to be the library that pulls in a lot of dependencies transitively and makes apps very, very large in size because those apps are eventually going to lose users because of that. You should also consider that you're just one of many libraries inside of an application. So if you have a lot of dependencies and everyone else also has a lot of dependencies, then that's really going to add up. And if you're doing well, then your library is going to be present in a lot of applications. So like multiply that, like globally, all the applications that include your library, you really want to minimize the dependencies that everyone has to pull in. Another good reason to have minimal dependencies is the complexity that it might introduce. For example, you can have version conflicts if libraries have a lot of dependencies. Let's say that you have a situation where you have an application that includes 2 different libraries, and each of them depend on app compat, but they depend on different versions. And this is a classic thing that happens during Android development. And when you're building this app that's being built on the 2 libraries, you have to resolve this dependency conflict one way or another. You might choose to keep the older version of the transitive dependency, which is the stable version. In this case, library 1 will definitely keep working well, but library 2 will now also call into the older version, and behavior might be different, or declarations might not exist yet that were introduced later on, so library 2 may crash at runtime. And the same thing can happen the other way around as well. If you choose to go to the newer version instead, if library 1 was using some deprecated things that have since been removed in newer versions, then that library might misbehave or just crash as well. So it's a good idea to have minimal dependencies, and you should notify your users if you're changing your dependencies if possible. We do this in our changelog. We have bug fixes and things like that listed, but we also list dependency version updates. For example, here you can see a changelog where we were bumping the Kotlin version and the Room version and Firebase dependencies and so on. We usually highlight the main dependencies that we change in the changelog, but sometimes we update a lot of dependencies at once. And in that case, we tend to link to the pull request where we've done that update. Since we're open source, we can easily do this. And we also have all of our dependencies organized in our build.src folders, which makes it really easy for clients to go through the actual pull request contents and take a look at what versions changed on what libraries, like you see in the diff here. Then you can also consider how to include transitive dependency inside your library. You can do this in 2 different ways. You can use an implementation dependency. In this case, you'll be able to use the code that the second library has inside it in your own library, but the app module won't see that code. They won't be able to reference anything from the second library. And but they will still pull in that library at build time, and it will be compiled into their final application. On the other hand, you can also include another library as an API dependency. In this case, even if the app doesn't include that library directly, they'll be able to use it. But they will be using it through your library, which means that the second library in this case becomes public API for your own library. And changing its version, or especially removing it, will now break the app because they might be relying on that dependency coming through your library and giving them making certain code available to them. Let's talk about how a library is shipped next. So when we package libraries, we package them into AAR files into Android archives. These are very similar to jar files, but they have some extra things in them that relate to Android development. For example, they have a resources folder in there, which will contain the layout XMLs and all other Android resources that you have, colors, string resources, and so on. They also have an Android manifest, which is quite similar to an application manifest. We'll look at this later. They have a classes.jar file inside there, which contains the compiled code of the library. So the Kotlin and the Java sources compiled down to bytecode. And it also has an r.txt that's just metadata for the resources. It just lists the declarations that the library has. Then you usually also ship some additional artifacts outside of the AAR. For example, you can ship a sources jar, which is a zipped version of all of your source files. This is what Android Studio uses when someone includes your library and wants to navigate into your code. This is how Android Studio can display it, by using this file. And you can also ship a Java doc, which is generated HTML documentation. Another file that's very important when you're publishing a library is the POM file, which is an XML file that describes some features of your library. Let's look at this up close. So first up, this has some metadata about your library. It will tell people the group ID, the artifact ID, and the version. We're going to look at these later on. But very importantly, this is where your dependencies will be when you're publishing your library. It's notable that you put your dependencies into your build.gradle file, but that build.gradle file will not ship with your library. Instead, the dependencies will end up here inside the POM file. And this is how apps that include your library will know what other libraries they have to pull in to make your library work. Let's take an example where you publish your library to Maven Central. And you also have some other libraries that you rely on, but they are hosted in other repositories, like you see here. And again, your library depends on these other second and third libraries. If an app comes along and they want to include your library, they can add it as a dependency using its coordinates in Gradle. And they will also have to add Maven Central to their list of repositories so that Gradle knows where it can download your library from to include it in the app. But since you are relying on other libraries that are published elsewhere, the Gradle process would fail at this point. You couldn't get it to sync because it would warn you that the other libraries are not available. So even though your library is published in this example to Maven Central, the app who's using your library, because of your transitive dependencies, would still have to include other repositories so that you can pull in those additional libraries. OK, let's say that you create a library and you're maintaining it, and it's growing, and you're adding new features, and it's getting larger and larger and doing more and more things. At some point, you might decide that it's doing too many things for a single library, and you want to split it into multiple different modules. You can do this by just splitting into different Gradle modules in the project, and they can also depend on each other. So for example, you can have some core module that has the original main functionality of the library, and you can have some other module that depends on the core module and adds some extra fancier things on top. You can publish both of these into Maven. And if someone only needs the core functionality and doesn't need the extra things, they can include the smaller artifact. Otherwise, they can include the larger one in their application. This is especially the case if your extra functionality depends on something heavy, some external dependency, for example, if it offers RxJava integration, or if it depends on something like Firebase or Play services. It might be a very good idea to split those parts of the library out into a separate module, so that if someone doesn't need those integrations, they can use a smaller, simple artifact, and they don't have to pull everything in all at once. Let's take the example that we have at Stream. As I mentioned earlier, we ship UI components. We have an offline layer, and we also have a low-level client below these. These are the 3 integration points that we offer our clients. They can choose which one they want to include as a dependency, and they can build their applications on top of that. But we also have this 4th module you can see at the bottom, which is a core module, which contains some basic models, some annotations, some utilities. And this is a separate Gradle module inside our project, just to better organize our code. And we have the client module depending on this. Currently, we publish all of these modules. So an app can choose to include any of the 3 top modules as a dependency. But we are technically also publishing the core module as a separate artifact. So if they really wanted to, people could depend on the core module directly. And this wouldn't make sense, but because we are publishing it, this is something they could technically do. What we would really like to do, instead of the client in its POM file including the core module as a dependency, would be to compile all of this together before we ship it. So we could compile a client module that just includes everything that was in the core module inside its classes.jar file and inside its resources, and it doesn't reference a separate core module in its POM file as a dependency anymore. This is something that's called a fat AAR, which means that it's an Android archive, which is fat because it doesn't have external dependencies. Instead, it pulls in those dependencies, especially if they're in the same project, and just builds all of it together into a single archive. And no additional things have to be pulled anymore from other sources. There's plenty of literature on fat AARs. Sam Edwards wrote about this a couple of years ago. Hiro Moos also wrote a great series of articles on library development where he mentioned the troubles with fat AARs. And there's an open issue on the Google issue tracker that talks about this. This, again, is 4 years old now. And the last update here is that they're talking to Gradle about being able to do this, but it has to be solved for the JVM first, and only after that can they add Android support to it. And this was half a year ago. So, wait patiently for this. In the meantime, as these blog posts and issue tracker mentions, there are some plugins that allow you to do something like this. There was an Android fat AAR plugin, which is now abandoned. Then there was a fat AAR plugin, which is deprecated. Then there was a fat AAR Gradle plugin, which I think is not officially deprecated, but hasn't been touched in 2 years. And now we have a fat AAR Android plugin, which shockingly is not the same as any of the previous ones. This is still a unique name in this lineup. And this one actually looks like it's maintained. It has changes in the last month, and it claims to work with Android Gradle plugin 4.2.0. This is very important because the reason why all of these plugins die eventually is that they have to continuously be updated to support the latest versions of the Android Gradle plugin. So it's very hard to rely on them. And if you want to use these plugins, you might have to lag behind on Android Gradle plugin versions until they can get updated. So right now, there's this plugin that's supposedly active. I'm not brave enough to use it in production or to try it in production. If you have used it, please find me somewhere and tell me about your experience. I'm just really looking forward to having an official solution to this. OK, let's talk a bit about your impact on the application, talking specifically about the startup impact first. So please, as a library, don't hog the startup time of an application. It can be tempting as a library to wish to be initialized immediately, to require your users to, in their own create methods, whenever the application starts, initialize your library and perform all of your setup immediately. But you'll be competing with a lot of other libraries, and if everyone wants to initialize immediately, even though they might not need to, they just want to make sure that they're initialized early, then it's going to really seriously impact application startup times. So try to defer this. Try to initialize parts of your library on demand if it's possible, instead of having to start up immediately when the application starts. Something you can use to behave better in terms of startup is the Jetpack App Startup library. Instead of the old trick of creating your own content provider and using that to automatically initialize your applications, your libraries, you can now use App Startup and its initializers, which will create just a single content provider, and it will call all of your initializers so that you can start your library's components automatically when the app starts. And App Startup also gives control to your users. If they don't want to initialize immediately, they can disable your initializer, and they can call it manually at runtime and initialize their library when they want to do it. Let's talk about logging for a moment. I want to ask you here to not log anything in the library by default. The reason for this is that there are going to be clients and applications who include your library. They don't configure anything on it, and they ship it into production immediately. And if you log by default, then you're going to end up with applications in production that are logging by default. So a much better approach is to have logging off, and instead let your clients enable it when they actually need it. For example, in the Stream SDK, we have a chat client that you have to initialize, and this is where you can pass in a parameter where you can enable logging when you want to. You can tie this to any logic in the application from here on out. You can do it depending on build flavors or whether it's in a debug build or anything like that. And the approach for logging actually applies to anything in general. If you just don't enable any library features by default, if you don't do anything magically, your users are going to be happier because you're not performing unexpected work for them that they never asked for. In general, you want to be mindful of performance, especially in a library. It's even more important than when you're in an application. You want to minimize the performance impact you have. A lot of the times, you're going to be in the inner loop. You're going to be the kind of code that's being called a lot because the application is a higher level thing and it's constantly calling into your library. So being more conscious of performance is more important here. And again, if your library does well, you're also going to be there in a lot of applications. So the effects of writing more performant code are going to multiply across a lot of apps and a lot of devices and users. Let's move on to some requirements and some thoughts about requirements. Again, this is something you should minimize, as I started the talk with this notion. You should make integrating your library as easy as possible. Usually, it should be just adding a dependency and initializing the library in some way, and that should be it. Don't force things in your clients that they don't actually need. We'll look at some examples of what I mean here. Don't make them configure complicated things if it's not a strict requirement. Don't have them add Gradle properties or modify their manifests if they don't really have to do it. One requirement that a library can have is a minimum API level. So here's an example of an application that includes 3 different libraries, which all have different minimum required API levels. Here, the application has to have at least the same minimum requirement as the largest API level that one of its dependencies has. So because the second library has a minimum API of 21, the application also has to, in general, have that same requirement. And if you're developing a library, you should try to have this minimum API requirement as low as possible. Even if you feel like people these days are not using anything below API level 23 or 21, you might have apps that are using your library that are operating with a user base where they have older devices, whether it's in a region where there are a lot of devices that are still being used, whether it's like some special environment inside a company where they have just one type of device that was never updated and they're still running Android apps on it. So make sure that you're going as low in terms of minimum API as you feasibly can for your library to still function. And also be very careful about bumping your API requirement upwards from whatever you select. For example, here in this case, if library 3 decides to change their minimum required API to API 23, they'll now force the app to also make a decision. Either they'll have to go back to an older version of library 3, which means that they can't get any bug fixes or new features, or the app also has to raise its own API level to 23 at the minimum, which can be a serious business decision in a lot of places. So if you can, as a library, don't make your clients, don't force your clients to make choices like this. Okay, getting back to what's in an AAR file, something we haven't discussed yet is the Android manifest.xml. So let's take a look at that quickly. If we open it up, again, as I said earlier, we see something similar to what an application manifest looks like. Something extra here is that we have the minimum and the target SDK versions specified here. Again, the reason why these end up in the manifest is because your build.gradle files where you're setting these are not going to be shipped with your library, so they have to go somewhere, and this Android manifest is where they end up. Then you also have a regular application block here if you're adding any content providers, receivers, or activities in your library. Those are going to show up. This is all as expected. And finally, you can set a bunch of requirements here. For example, permissions that your library needs or hardware features that it might require. Everything that you put into this manifest will be merged together with the rest of the application. So anything that the application manifest has and anything that other library manifests contain will all go into one single large manifest file, which means that if you add a permission here, it will also become a permission in the final output of the application. So you should be careful about doing this, about adding too many things here. If your library doesn't strictly need a given permission, don't add it here by default. Instead, you can ask your clients to include that permission if they want to have like that specific functionality, like camera, for example, inside your library. and you can check for it at runtime whether the permission is available or not. Similarly to how the manifests of all the included libraries and the application itself get merged together, so do the resources. So all the resources that libraries and the application itself has will be merged together, which means that if resources have the same name, they might conflict and override each other. For this reason, it's a very good idea to have resource prefixes in a library, to have some prefix that's unique to your library and is unlikely to be used by anyone else. And you can just do this manually by going to your resources and prefixing all of them with the same string. But you can also do Gradle configuration for this. For example, in the UI components that we ship, we have the stream UI resource prefix configured in Gradle. And then to comply with this prefix, we have color names like these, which all start with the same common stream UI prefix. If you set this up in Gradle, Android Studio will give you tooling help for it. So if you create a resource that doesn't match the prefix specified, then it will give you errors on it and tell you that you have a resource prefix in your project and you might want to rename this color here. Luckily, if you don't want to use snake case for all of your resources, for example, for attributes, we prefer using camel case, like you see here. Android Studio is flexible enough to understand that these are also correctly prefixed with stream UI, despite the resource prefix being specified with underscores in snake case. And as an additional bonus, whenever you're creating new resources, like extracting a hard-coded string, you'll also automatically get Android Studio's tooling to kick in, and it will pre-fill the prefix for you as you're naming the newly created resource. So resources can get into conflicts, and another problematic part with library resources is that all of them are public by default. This means that an application that includes your library gets to use all of your resources anywhere in their application. This means that they might find a color, a string, or a layout in your library, and whether intentionally or just accidentally, they might start relying on it in their application's code. For example, you might have like a button OK string in your library, and if you ship that, they might start using that for all of their dialogues in the application. This means that these resources are part of your public API, so you can't rename them or remove them without breaking applications. And this is where private resources come into play. In order to not expose all of your resources, you can add one or more public resource declarations into your resources folder, such as these here. And the way that these work is that if you don't have any public resources declared, then everything by default is public in your library, as I just mentioned. But as soon as you add at least one public resource, everything that's not listed as public will become private. So you can't specify private resources, but you can specify explicitly public resources. And then everything that's not exposed, that's not listed with these public declarations, will be hidden from your client. All right, let's go back just once more to this view of the AAR file and take a look at one more file that's in there that I didn't talk about yet, which is a ProGuard file. So whenever you ship a library, you have the ability to ship ProGuard rules with it. If we open up this file for one of our Stream Chat libraries, you'll see that we have just regular ProGuard rules in here. These work the same way as the manifest that you ship in your AAR file. These ProGuard rules will be merged with all of the ProGuard rules of the application, as well as the ProGuard rules, of all of the other libraries that are included in the end user application. You can use this to keep classes to make sure that some classes inside your library are kept, even if your users run it through ProGuard. For example, we have a lot of model classes around networking that we want to make sure are not stripped. You do have to be careful with this because these rules will not apply just to your AAR specifically. It will apply to all code in the application. So if you do something like keep all serializable or all parcelable classes, then you will keep a bunch of things that are not inside your library, but are just elsewhere in the application. And you can also completely break ProGuard here if you want to. If you decide to include a don't optimize or don't shrink option in your ProGuard file that you ship with your library, you can just disable ProGuard for the entire application. So be very careful with including too many things in there. How do you get rules there? This, again, is some Gradle configuration. And the same way that you can specify the ProGuard files that should be used if ProGuard is executed within your own current project, you have a consumer ProGuard files option in Gradle, and you can specify the file that you want to ship as the consumer rules. This is usually consumer ProGuard rules.pro, and it should live in the module that you're working in, and it just contains regular ProGuard rules inside it. I wanted to talk a bit about testing here, because testing libraries is more difficult than testing applications in general. For one, it's a lot of responsibility. All of your users have apps that are going to include your library. And if your library has problems in it, if it has crashes in it, you're going to start crashing a lot of users' applications as they update. In theory, all of your users should test their applications, their own applications, after they've pulled in a new version of your library. But in practice, a lot of them are going to skip this, and you're not going to be accountable, but they're going to feel like you're not going to be accountable for this, but they're going to feel like you are responsible for breaking their applications. So either way, they're not going to be happy with you. You also have to be prepared that your code is going to run in a lot of diverse environments. You really can't assume anything about where your library code is going to get executed. This is true in general on Android as well. We have a lot of devices, OS versions, CPU architectures. But with libraries specifically, there are even more challenges. For example, if you're an app developer, you might know that your app is always distributed through the Play Store. But if you're building a library, the apps that are built on it might not be distributed through the Play Store. They might use other stores. They might be distributed as APKs. Anything like that can happen. So a lot of unexpected things can happen in terms of the environment where your library is going to be used. For example, the device might not have Play services on it. You have to be prepared for things like this. Also, it's going to run in an environment where there are also other frameworks and libraries packaged into the same application. One issue we had recently is that whenever clients used our SDK with Dagger Hilt, they would see some crashes because we were making assumptions about context wrappers that Hilt would break because it would introduce some new things into the context hierarchy. So this, again, is something that is kind of hard to test for, but you should attempt to test your library when it's being used with other popular libraries, Dagger, OKHTTP, whatever it might be. And it's important to remember that your code is not final as you're shipping it in your library. Your code is going to get merged with a lot of other things, as I've just mentioned. The manifest and resources are all going to get merged between a lot of different libraries and the application's own code. So conflicts might happen there. Things might be overridden. And for example, your code will also be processed probably by ProGuard when the final application is being built. So that might also mess up your library if you, for example, forget to ship ProGuard rules with it. OK, let's move on to documentation. First up, have documentation. If you have a library that's amazing and nobody knows how to use it, your library is not going to do well. If you're on GitHub, and you should probably be on GitHub these days for open source Android libraries, you should have a README. The README should tell people what your library does concisely. It should have some basic setup instructions where the library can be grabbed from, what repository, its Maven coordinates of what to include in a build Gradle file, and also some like initialization examples. If you're a UI library, please add some screenshots of your library so that people know what to expect when they add it to their applications. One thing that's important to note is that your README doesn't have to be your full documentation. If your library is doing a lot of complex things, it doesn't make sense to try to put all of that into the README. You might want to use the GitHub wiki, or you might want to have a separate website, which you can also host on GitHub pages if you want to get away with it for free. And you can have just the basics of the information in the README and then link to an external resource. But it's important to have the basics always in the README so that people can reasonably discover what your library does. The next important step is to document your code. This doesn't make that much sense usually in end-user applications. But if you're writing library code, a lot of people are going to be reading that source, either through IDE tooling, which will pull in the sources and display it in autocompletion and in other places, or by just jumping to your code directly when they're developing with your library. Something you can do to make sure that you have documentation is you can go to your inspection settings, and you can search for an inspection called missing kdoc comments for public declarations. If you enable this, you're going to get warnings on all public declarations that don't have documentation on them, classes, methods, and so on. So this can remind you to add the documentation wherever it's missing. If you want to be strict about this, you can also set the level that you want this inspection to have, so you can make it give you an error instead of just a plain warning. Something else that's really handy to have is a sample app for your library that just shows clients what it looks like if they include it in a real application and what the integration code should look like. With the sample app, I want to warn you to make it as simple as possible. Don't mix in unrelated things. Don't have your sample app include examples of RX and Dagger hilt and an MVI architecture if those things are not essential to using your library. If you're an image loading library, have an activity, have an image view in it, and have 5 lines of code that load an image into that image view. And as with all documentation, have some kind of update strategy. Nothing's worse than documentation that's completely out of date. So have some idea of when and how you're going to update the documentation as your library is changing. And also just review the entire documentation every once in a while. All right, we're coming up on the last section of the talk, which is going to be about publishing. You're going to be publishing your libraries, hopefully, to Maven repositories. Don't let this confuse you. Gradle just uses the same repository and dependency system that Maven used to use. So there's no Gradle repositories. We just have Maven artifacts and Maven repositories, and those are being used by Gradle. The only real alternative to doing this would be to distribute your library by hand, so by sending your clients AAR files after you've built them. Some enterprise libraries and frameworks do this, but it's very painful to integrate these into applications. They can't have dependencies. They can't have external dependencies because there's no POM file attached, like in when you're pulling it from Maven. It's very hard to update to new versions. So please don't do this if you're an open source library published to a Maven repo. You have some main options, and I've seen these being discussed in the chat as well. So let's talk about the popular options we have for Maven repositories on Android. The first one is going to be JCenter, which used to be very popular. It was a default repository in Android Studio as well. So basically every existing Android project already has it added. And it was very popular as well because it was very easy to publish into. Earlier this year, it was announced that JCenter is sunsetting, which means that they are no longer accepting new artifacts, and they are supposed to be serving all existing artifacts even beyond their sunsetting dates. They're saying indefinitely, but I don't know how trustworthy this is. So if I were you, I would try to reduce my dependency on JCenter. It's also just a good idea to not have, as I've shown you a while back, not have dependencies on libraries that are available from other repositories than where your own library resides, because then you're forcing applications to include multiple repositories, even though they're just including your library. We at Stream have removed our JCenter dependency a couple of weeks ago, and so we're now just on Maven Central, and we have some Jetpack dependencies because we couldn't avoid them. Also, JCenter used to have security problems, at least some security problems. It was very easy to publish to, which also meant that people could publish fake packages. I posted an article about this a couple of years ago where I described example of this, where someone with a fake jQuery user was republishing libraries and injecting their own code into it. So if you pulled in a library and JCenter was too high on the priority list of available repositories, you would pull in these fake packages by default in Android Studio. And, well, they could essentially inject arbitrary code into your applications with this. Another option is Jetpack. Jetpack is a really convenient way to publish your libraries when you're getting started. This is their like getting started guide. They basically allow you to just push a library to GitHub and use Jetpack as the repository that will serve it. So you can specify a GitHub repo by the username and the repo, and you can also specify a tag or branch or commit hash. And Jetpack will grab the code from GitHub, it will build it into an artifact and serve it to you as a Maven dependency. This is really convenient. If you trust Jetpack, it's also safe. If you trust that they'll only build what's in the GitHub repository and only serve that to you. The problem here is that you don't have very precise control of what's going to end up in your artifacts. And it might take some time for dependencies to be pulled if Jetpack has to build them from scratch, if you're the first person who's pulling in something. And just like anecdotally, I've had reliability issues with Jetpack in the past, so I don't really like using them. And then the third main option is Maven Central. Maven Central is like the place to be if you're a Maven dependency. They have verified users. They make sure that you're only publishing artifacts into domains that you actually own. They require you to sign your artifacts and jump through a bunch of hoops to get in there. So it's very secure, it's very reliable, it's great, but it's also very hard to publish to because you have to go through a bunch of steps. To make this easier, I wrote an article 2 years ago about how to publish to Maven Central, and I've released an updated version of it earlier this year, and I'm continuously updating it now so that it always has an up-to-date setup of how you can get an Android library to Maven Central. We're also using the same setup in our Stream Chat Android SDK. So if you go to our GitHub repo, you'll always find the actual working setup that we're using to get our artifacts to Maven Central. OK, some tidbits around publication. If you want to publish, you're going to have to choose your coordinates, which looks something like this for a Maven dependency. These have 3 different parts. First, the group ID is quite important if you want to publish to Maven Central. This can either be a domain that you own. So if you own the example.com domain, then you can use com.example as your group ID. Or if you don't own any domains and you don't want to buy one, you can also use your GitHub username. So if you have a username on GitHub, you can use io.github.username as the group ID. The artifact ID is arbitrary. You can put anything in there that makes sense. So just use the name of your library. And the version is something you should think a bit more about. Here, what I'm advising is that you should use some kind of a versioning scheme. There are very strict ways of versioning software. For example, there's semantic versioning, which is quite popular. I don't usually adhere to this very strictly, but just having some kind of versioning strategy and not introducing breaking changes in small version bumps is a nice thing to do for your clients. Finally, you should give your library a license. On one hand, there are going to be companies who can't use libraries that don't have licenses. And on the other hand, if you want to go to Maven Central, that will also require you to choose a license. There are sites that can help you with this. For example, there's tldrlegal.com that gives you basic, short descriptions of what each license requires. Basically, almost every library that's open source uses MIT or Apache 2, and you can't really go wrong with either of these. One last thing about publishing, I always have a release checklist for my libraries when publishing them gets complicated. For example, here's my checklist that I use for publishing Rainbow Cake. Here I have instructions for myself to bump the versions in the build Gradle file and in the project README to create a new release notes markdown file where I create release notes and list whatever has changed. And then I'm telling myself to merge everything to main, to create a new GitHub release and make sure that I'm using the main branch to create that release because it's not the default branch. Then I have a step where I just wait for GitHub Actions to deploy my library to Maven Central. And finally, I have some notes here which tell me to update the documentation and also the example projects that live in different repositories. So building this kind of checklist, if you have a lot of things around your library, is really handy to make sure that everything is kept up to date. OK, we're coming up on the last slide, which is all about community. There's a big difference between having an open source library and having a source available library. What I mean by source available is that there are a lot of libraries that are just technically open source. They don't really participate in the GitHub community. They have a GitHub repo which is updated on every release. They are mirroring some internal branch to GitHub so that their code is published. But I would not call these libraries open source. To actually participate in open source, you should address issues and discussions on GitHub, for example. Discussions are a new feature which are more of a Q&A style conversation on GitHub. You can choose whether or not you want to enable it, but you should check it out. It's quite interesting. Also, you can take pull request contributions on GitHub. That's a very friendly thing to do. To make this easier, you can have a contributors guide, and you can have pull request templates so that people have an easier time creating proper pull requests for you to accept. And finally, be open for feedback, but this comes with an asterisk. And here I'm going to quote one of my colleagues, Philip, who told me about a month ago when I was actually interviewing him for his current role, that you're supposed to side with the community, but you should also have a say in what you're building. And I think that's something that's very important to remember as a library author. It's very easy to go down the path where you're just listening to your community and looking at the feature requests, and you're trying to do everything that the community is asking you to do. But at some point, you're going to lose the coherence of your library this way. So be open for feedback, but also have some vision of what the library will do and what the library will not do, and what should be implemented like separately if someone wants a given feature. All right, with that, we're at the end of the talk. I want to highlight some resources very quickly. I'll give you a short link to all of these in just a moment that you can go to browse them, but I just want to highlight some of the things that are going to be in there. Nish had some amazing talks in recent years about building Android libraries. I've pulled some points from both of those talks. If you want to go into more technical details, you should watch those. Then I want to mention some of my own content. For example, the mastering API visibility in Kotlin talk that I mentioned at the very beginning about public API, as well as the guide to publishing to Maven Central, which you can find on Pro Android Dev. Then there is this series of library development articles that I also mentioned during the talk by Jeroen Moos. And this, in the second part, talks about fat ARs, which is quite interesting. And the third part is a great summary of what you can do about dependency conflicts and how you can resolve version incompatibilities and things like that. This includes a lot of technical details that I didn't want to get lost in here. And finally, I have some things about fat AARs here. Please go to the Google issue tracker and start the issue so that we can get official support for that. All right, that's it. So if you want to grab these slides or any of the resources, or even additional resources that I didn't have time to mention here, go to my website and my talks page, and you'll find everything there already. And if you want to follow me and hear about Kotlin and Android and Jetpack Compose stuff and all of that, the best way to do that is on Twitter. You can also find me there if you have any questions that I'm not addressing here during the talk. OK, so that's a wrap. Again, to conclude, minimize everything in the library, basically, meaning your public API, your dependencies, the size, and the impact you have performance-wise on the application that's going to include you. Make sure that you have everything figured out around publishing and releases. And of course, don't forget the documentation, because otherwise your library is going to be very hard to use. OK. With that, I'm going to go to the Q&A and see if we have any questions that I can answer. I'll also grab a drink while I'm taking a look at those. All right. The first question is how to implement Dagger-like DI in library module. That's a good question. Dependency injection is a lot easier if you're in an application and not in a library. As far as I know, you can technically do Dagger inside the library if you really want to. But it gets complicated, and I've never actually seen it used in practice. So in the library, I would usually just recommend doing manual DI, maybe relying on Coin or a service locator like that. but usually you can just get away with writing DI code manually. What's your take on introducing kill switch upgrade flag in SDK to ensure that latest secure version is used? I guess for some critical SDKs, it could make sense. If it's like a security requirement, if you're handling money or something like that, to remotely be able to kill your SDK. I never encountered something like that, thankfully. Shouldn't all Android libraries also have a no version of the library to make it easier for devs to use them where they don't want an extra call of its functionality in case of, say, debug builds? I don't know if it makes sense for all Android libraries, but it makes sense for some Android libraries for sure to have no versions. I wouldn't go as far as doing it in all libraries. Usually, if you want to separate a library for like testing purposes, you should be able to just wrap it in your own code and separate it out like that. Is it a good practice to use ProGuard for debug? I guess the question here is to enable ProGuard for debug builds so that you can notice earlier, like during your development, if ProGuard is causing any issues when your library is used. I wouldn't go as far as using it in debug builds because it just has too much of an impact on build time and performance. But it's a very good idea to test the release version of your library, the ProGuarded release version of your library before you ship a new version. Considering you want to minimize dependencies on which your library depends, how do you solve networking inside your library? Do you write everything manually? Good question. This is going to depend on how far you want to go with minimizing dependencies. I think at this point it would be too tedious to write networking code inside a library that builds on like HTTP URL connection and things like that. I wouldn't go that far. In Stream, for example, we are using standard networking solutions. We're using retrofit OKHTTP and things like that for our networking needs. The rationale there is that we're trying to use the most standard solutions possible. So if the app has any other networking, they will likely already be including these dependencies anyway. So we're not really adding anything extra on top of it. Something else you could do if you wanted to be really, really lightweight with your library is that you could make the networking part pluggable so that your users can plug in whatever networking library they use and have like a retrofit implementation and other implementations as well. But it sounds like a lot of extra work. So either you go very low level and do all of the tedious work of not using these higher level APIs, or you just try to pick a very popular solution and hope that it's lightweight enough and people don't mind it. What would you suggest to bundle using FetAAR versus making it an SDK dependency? Yeah, so when it comes to FetAARs, the point is that your clients shouldn't necessarily see the same structure in the Maven repository that you have in your local Gradle project. So if something makes sense for your client to include individually, then you should publish that as a separate artifact. Like, for example, if the core module does something good on its own that can be used, then it makes sense to ship it separately as an artifact. But if you just have like 5 different modules within your Gradle project so that things are easier to navigate, but none of those should be included, only the top level one that depends on all the others in an actual application, then it would be great if you could build a FetAAR that just has all of the smaller modules inside it. Again, supposedly you can use plugins for this. I haven't been brave enough to try them. Should the analytics collection be enabled by default? Is it okay to send some analytics and logging data to your server by default? Yeah, that's also something that I would be very, very careful with. There are going to be developers who will include your library and not configure anything. And if you start collecting data on their users, I think you're going to be susceptible to ending up in bad situations with that. Like they will likely not ask their users to give them permission for your library to log data and process it in whatever ways. So yeah, analytics, I would definitely disable it by default. How is it possible to have something like Crashlytics but for Android libraries? I don't know the answer to that. As far as I know, in a library, you don't have the ability to catch arbitrary exceptions. If your library code can be surrounded neatly, if you can wrap all calls that go into your library somehow, then you could catch exceptions at that level, but it sounds very difficult to do. So yeah, that's a hard problem. I'm not sure what to do about that if you have a real need to track crashes. In Android, all popular libraries have a root Gradle file with variables for its dependencies. This conflicts when other libraries use the same variable name. Okay, I actually don't quite understand this one. So build.gradle files that the libraries have should not conflict with each other because they are not shipped. So I'm not sure what that question's about. Should libraries ever throw an exception or return an error object? It's up to you. That's part of the API design. There are a lot of approaches to that. You can use result types. You can throw exceptions. Make sure it's documented, and if possible, do it consistently in the library. So, don't build APIs where one function is going to throw and another one is going to report an error with its return type. Try to be as consistent as possible so that clients can figure out what your error handling strategy is and use it correctly in all places. Okay, it looks like those are the Q&A questions we have so far. I have some things in the chat, but I'm gonna have to look at those links a bit later because there's a lot of explanation around that.
I was gonna say I was gonna offer your time on your behalf and volunteer you to stick around. The room is open till 6:30 release time, so we got about 15 minutes. There is another question just popped up in the Q&A, whether you can use CI/CD in the library. That maybe you can take that one really quick, and then I'll send everyone back to the floor. And I know there's a couple questions. Maybe people can find you at one of the tables and chat with you then.
Yeah, the CI/CD question, absolutely you can. You can use CI to run tests. You can use it to build your library, to publish its artifacts, just like you would do it for an application. The Maven Central Publishing Guide, for example, includes GitHub Actions setup that will run your tests and, well, not run your tests, I guess. I think it has a GitHub Actions setup that will build your release builds and source jars and all of that, and push it to Maven Central for you. So yeah, CI definitely makes sense for libraries.
Perfect. Márton, thanks so much again for being with us. And also, by the way, a big thanks to Stream on this. Stream has been such a fantastic supporter of DroidCon and our webinar series. We're going to send everyone back to the floor. If you have any questions, hit Márton up for some one-on-one or the group chat. And also feel free to click on the Stream logo as well. That'll bring you to some information about their messaging chat APIs, SDK. I think it's good stuff. And also there's a lot of things, obviously, that were referenced in the presentation that they've done a really good job of implementing there. So again, Márton, thank you so much for being with us again. I always look forward to having you, enjoy having you, and look forward to having you back again with us. Yeah, thank you so much. I look forward to seeing everyone in the rooms. All right, we're going to send you back. Thanks, everybody, for attending. Take care. Bye-bye. Bye.